Digital twins is a topic that is discussed throughout all areas of the AEC sector, so the architecture, engineering, construction world, for within which me, as the manager of the solutions engineering group, I probably spend more hours of my day talking about that and what it actually means, and also what it doesn't mean to folks. And so, what Esri has done, led by Christine Ma, we've put together, like, Esri's approach to this. What does this mean? How is this of value to companies? For me, when we're talking about digital twins, it's being very clear about what it is. It's about having the representation of, the built, the environmental and the social worlds that we have, and the role that GIS plays within this is that we provide the connective tissue throughout all of this, because everything exists somewhere in the world. Every project exists somewhere on the planet of the Earth, or on Mars for that matter. We're helping out some work over there. What we were looking at, though, was based off some work that was done by the Gartner Institute recently about the Gartner hype curve. I'm sure many folks are familiar with it. Digital twins as a phrase has really dropped into this trough of disillusionment. You sort of mention it at a conference, or when I'm talking with one of those very large construction or consulting firms, and they're just saying, whatever, Andy. I was like, yeah, you're right. So why am I still talking about digital twins? And the flavor of this. And really the reason we're talking about it is because Esri is looking ahead. We're already looking out to see what the value already is. And we know that this is of value to companies. So we're talking about what Christine's work has done, what I'm helping her present, and we discuss about, is about planning ahead. And the reasons why we see this, why we know this is what's coming, is in part, if we're just looking at the US, some of the spending that's happening on infrastructure. Again, infrastructure is projects. Projects exist in space. If we want to build these projects, we want to have an understanding of both the built, the social, and the environmental world within which all of this operates. So not only is the US government spending an inordinate amount of money on these infrastructure projects, the same thing's happening throughout the world. Again, some rough stats that last year, somewhere in the industry total was somewhere in the order of $10 to $12 billion, of which there's about an $8 billion geospatial market. The projection, again, this is all about this looking forward. Why do we see value in this? Why do we think companies need to be involved? Is that's projected to increase about fourfold. So we're talking somewhere between $45 to $50 billion by about 2026. Geospatially, that's sort of meaning somewhere around the order of like $20 to $25 billion worth of work. And if a consulting firm doesn't want to be involved in that, I'd have to question, like, so what do you guys do? But that's so this is why we also know that, as we discuss with a bunch of companies, and a lot of the time that's what I'm doing is talking with firms, is that about 3/4 of firms, of owners, of operators, they want a digital twin. They want a method to answer questions more easily, the challenges that they're facing. But what we realize, though, is that I think it's about 10% or so of them have actually got something in place. So there's massive gap between folks that want something, folks that have actually got it. So what we've gone and done is really make use of the existing technologies, the role that GIS already has, looking at the landscape models, modeling the Earth, modeling the world. This is something we've been doing for decades. Then you start adding into that, building information models from the design world, from our Autodesk partnership. Start looking at networks, so all of our rail, our water, our power, our telco networks can all be brought into this world as well. And then you start adding onto that from across cities. You start looking at the urban planning, which is really sort of the core of where Christine's work had come from, and some bloody impressive work too, by the way. For us, that's what the core of these digital twins, Esri's digital twin platform, is really all about. It's not about a singular digital twin, one ring to rule them all, so to speak, but it's about bringing together information so that different groups can view that same content and extract the information they need to answer questions they have for the particular challenges they are faced by, and tackle that piece. Now, that may be in the way of, one may look at it about being an environmental twin, where you're pulling together all the environmental variables that are happening. Maybe you've got IoT sensors, stream gauges, doing bird counts and so on. Perhaps I was looking at sort of more of a design. And my background was in design and mining. So maybe you're pulling together the design information to plan out what are the options and variants that you might want to look at as you go through. Start looking at operational twins, and then even network twins, again, where you're assessing information that's coming out of a singular environment, but viewed by different people to answer different questions. And the piece that wraps around that then is our urban planning twin. So again, we want to understand how best to make use of our space.
By definition, right, digital twins are virtual representations of the real world, including physical objects, processes, relationships, and real-time behaviors. And we believe GIS creates digital twins of the natural and built environment, and uniquely integrates many types of digital models and systems to create the common data environment. And the fact that GIS users have been creating, analyzing, modeling, and integrating digital twins using ArcGIS for quite some times by now. We just haven't always called it a digital twins. So for example, a lot of our users have been using GIS to build landscape information models, the terrains, the topographies, and also the environmental layers. They've been using GIS to manage networks, such as ArcGIS Utility Network, to manage linear assets and connectivities. They've also developed city information models that support urban planning, project review, and citizen engagement. And you've also been seeing GIS integrated with BIM or building information models to visualize and analyze highly detailed representations of structures and also facilities. To demystify digital twins, we developed a diagram to help show how it can support different sectors and project life cycles through a platform approach. So you can see at the foundation, we establish a connected data environment that leverages reality capture data and streamlines the connection between different data types. And then on top of that, our proposition is to twin individual subdomains by defining the workflows and needs of different user groups for their desired outcomes. So basically, we start with a problem that we like to solve, then construct a twin or a view that helps us address it. So we can create various types of views that manage, visualize, and model complexity and interdependency of systems in a tangible way, all based on a common connected data environment. So the twins are interconnected, which means that data, visualization, and insights can flow across the twins and inform decision-making for each user groups. For example, for environmental analysts, for urban planners, architects, construction and operations managers at all life cycle stages and development scales, including region, city, neighborhood, all the way down to the infrastructure and facility level. And this is also a flexible framework, as you can add additional views based on your end user persona and your projects. For example, when sharing this framework with local governments, some have suggested creating a utility twin or network twin to monitor utility distribution and usage. We also had conversation with AEC firms around establishing an engagement twin with leveraging virtual reality and gaming engine technology to create engaging experiences for their end customers. And supporting it all, the digital twin platform is built on the foundation of enterprise GIS, which continuously updates the data and integrates with other systems to keep the twins current and accurate.
There's a lot of discussion around 3D. I need a three-dimensional space. I need a laser scan. I need photogrammetry. I need an ortho images. I need my mesh that's been captured from my drones. And yes, absolutely, that is important, but it's not the be-all and end-all by any stretch. It's one of the steps to get along to it as we go, and you need that information to be able to start building up a picture of the real world, so that you can then start to run digital scenarios against that, bringing information into that, testing your ideas, asking the questions and running the analytics as you roll along. The planning twins that we talk about are urban planning twins, looking at our built environments, very much gets into understanding the overlays of cities. Where do we go and do our building? Where do we want to have new developments go in? What's the impact of those developments, not just on the individuals, but the movement of traffic, the access to green space, the urban fabric that's there that people actually use, the shops, the schools, the sporting facilities. But also then looking through what's the potential costs and the growth that may happen, because as a city grows, these needs will differ as population ages and changes throughout. We can go from starting off of having just your standard sort of desktop views of buildings and shapes and massing, and yes, pulling in the data and designs from Autodesk, where somebody's done some amazing architectural work. Let's look at the initial idea, the strategic planning side, and then we work our way down through the next level of detail, then into the next building, bringing in our built forms, and then the impact to the infrastructure that rolls on, because it's never just one building. You put the building in, well, I need to redo the side work. Well, if I'm doing that, I better redo the drainage and the gutters, and now I need to redo the road. So it's all interrelated. And then, yes, you can take those designs and then push them out into the virtual reality. Again, helping communicate the changes that may be coming, the impacts, the opportunities that people have. So really sharing that information out through, put on the Oculus, or putting on the virtual headsets, doing it off your phones or your tablets, and giving people that sense to feel connected and understand what's actually coming. So for us, the role of a digital twin is far more than here's a pretty picture. I mean, that's a piece of it, but it's really about bringing information together so we can make informed decisions and be confident in those decisions to roll on and do whatever comes next.
So this is all made possible through the power of ArcGIS, because location is the ultimate integrator of various data types and models, which allows ArcGIS to provide the common data environment that become the foundation for digital twins. But what does it mean to really bring this down to earth and really make it real? So to demystify digital twins, we developed a diagram to help show how it can support different sectors and project life cycles through a platform approach. So at the foundation, we establish a connected data environment that leverages reality capture data and streamlines the connectivity between different data types. And on top of that, our proposition is to twin individual subdomains by defining the workflows and needs of different user groups for their desired outcomes. Basically, we start with the problem that they like to solve, then construct a twin, or you can think it as a view that helps us address it. So we can create various types of views that manage, visualize, and model complexity and interdependencies of systems in a tangible way, all based on a common connected data environment. So the twins are interconnected, which means that data, visualizations, and insights can flow across the twins and inform decision-making for each user group. For environmental analysts, urban planners, architects, construction and operations managers at all life cycle stages and development scales, including region, city, neighborhood, all the way down to the infrastructure and facility level. This is also a flexible framework, as you can add additional views based on your end user personas and projects. For example, when sharing this framework with other jurisdictions or AEC firms, some have suggested creating a utility twin to manage and monitor utility distribution and usage. We've also heard from other customers around establishing an engagement twin where we leverage virtual reality and gaming engine technology to create engaging experiences for their customers. And supporting it all, the digital twin platform is built on the foundation of enterprise GIS, which continuously updates the data and integrates with other systems to keep the twins current and accurate. So that's essentially the digital twins platform that Esri proposed and shared as approach right around the digital twins. For operations twin, it can cover multiple scales, right? I think the example you see on the screen, we can see the live feed of traffic, but it can also function at the facility management level to enable facility managers to view operational metrics for one project or across a wide array of projects and sites. So the users can create operations dashboard related to KPIs on energy consumption, carbon emission, and occupancy. For example, we have solutions like ArcGIS Indoors that can help establish this type of dashboard and view for facility managers. But it can also be at the citywide or county-wide level to communicate the current performance of an actual system through a 3D interactive and explorative experience, often with live feed and alerts. So here we can see an example of how we can leverage the operations twin to monitor activities in real time and use that information along with historic data to support decision making. So through this operations twin, we have a complete picture of real-time data feed and alerts, historic analysis, data analysis, and graphics to show how things are connected. So here we can see all New York City bus lines and active buses in real time. We can also see where the buses have a hard brake, giving us insight into traffic patterns and risks on the road. And now in this view, we are running, we can also run, big data analysis. So looking at historic data of 6 years of traffic incidents in New York City, we can see around 5,000 here on the Midtown bus line. We can select the peak day and time, and looking at Monday 4 p.m., filter to a specific area, Washington Heights in this case, and open up a graph diagram, which shows us how the data is connected and their relationships. So we can select a specific node for one bus and look at the 2 drivers for that bus and also the number of repairs that have done on the bus and explore what parts of the bus were repaired. And this is just a quick example of operations twin, right? We are able to analyze real-time data. We are able to monitor existing condition and also provide insight on how we can operate more safely and efficiently for this system.
So once we've taken a capture of the real world, so the reality meshes, we've added in different layers of designs of planning information that we may have for a city. For us, really, the next big step and the main point to be aware of is that a digital twin needs to be something that is continually evolving and updating. The scenarios can be run within it and then pushed back into the real world, and then vice versa, that these models are then taking input from this. So IoT is an absolutely foundational aspect of that. And also both the IoT side, but also then moving into something that I think is going to be fundamental for digital twins, and it's making use of knowledge graphs, of link and node charts. So things like a Neo4j side of things. It's looking for these relationships between items and objects that don't have any other connection other than spatial. The IoT side of that falls very much in that space. We need these sensors to be informing the scenarios and the models that we're running, so that then from there that we can then go back to actually update the real world and then adjust it and then continue to monitor and model those sort of things. So in terms of the connectivity of information, yes, it's everything from the enormously small scale that covers the entire continent all the way down to the nuts and bolts and the water flow pressure within a particular pipe. So yeah, IoT is definitely something that needs to be included. Now that said, a digital twin doesn't have to be that for everything or for everybody. Discussions with one company was that their digital twin wasn't even in 3 dimensions. It didn't need to be. To answer the question they had to run these scenarios, it didn't need to be a 3-dimensional thing. It was a 2-dimensional network grid, worked a treat. Had IoT sensors on it. They were feeding information to and from. It was going out into the field. But yeah, I think for most folks to be aware that a digital twin isn't one thing, and there is no one piece of magical software that solves this for everybody, for everything. It is invariably going to be a consulting engagement to bring together multiple tools to answer the questions somebody has.
Yeah, I think there's some examples. Ooh, it's not on this slide, but we have examples around, traffic, wayfinding, flooding analysis, and this is also tied closely to the environmental analysis portion or the environmental twin. Really looking at how the data and analysis can support sustainability advisors and the environmental planners based on their workflow and their project needs to deliver things like climate vulnerability assessment, urban heat analysis results, or natural risk, like flooding risk, right? The analysis results can also be consumed by the end user on demand and interactively, like we we're seeing in the example earlier. And I also want to list some examples of the environmental analysis or the environmental twin, to really looking at forecasting, right, of winter storm, droughts, flooding, looking at carbon footprint, monitoring things like sea ice, tracking fish movement, looking at water quality. And that's one thing I really want to emphasize is that these twins are interconnected, right? So based on what problem we want to solve, for example, the sustainability advisor and environmental engineer can analyze climate vulnerability in terms of sea level rise in an environmental twin. And that visualization and insight can flow into a planning twin to inform planners, right, on where to build, right, and also on zoning and development policies to avoid building in high-risk areas. And their performance-based planning scenarios will then inform architects and construction managers, right, to really in a design and construction twin to determine, right, really what the building will look like, and all the way down to an operations twin to monitor and track operational metrics across multiple scales, right, from the city all the way down to the building level. So that's kind of the example or the example or the connected digital twin that we want to share, right? It's not just one data point at one point for a specific system, right? We're really looking at connected systems and connected database to support it. For the example, for the New York City bus system, there is live or near lifetime alert that's set up to inform drivers on the traffic, right, and also on the heartbreak of the specific areas is either looking at related to the traffic pattern. So that's if there's a need of real-time alert, right? Then we want to set up the systems and also the having the data to support it. But we're also looking at historic data to help us analyze, right, where the high risk areas for, or the heat map for traffic accidents, right? So being able to do that analysis is also important in decision making. So it's again, come back to what is the problem that our end user want to solve, what kind of data we need to acquire, right, to solve that problem. So I guess it's really come down to delivering the right data, the right insights into the right end users and through the right interface, right? So that's really where I think the Esri solutions can support and establish the digital twins for our end users.
Across all of the sectors, the architecture, engineering, the environmental, and construction side of things, being able to understand what the question is that's being asked, gather the content that we need to be able to answer this particular question, and then come out with an outcome, a result, a pathway forward as quickly as practical while still being confident. That for me, that's the ultimate goal that we want. And that's the value to AEC of this broad methodology that we're all referring to as a digital twin. Going forward into the owner's side of things, the owners and the operators, for me, having this information gathered under the broad banner of a digital twin is enabling them to go and do that. Instead of starting from zero, you finish the project, hand the data over, loses its brains, and you're starting again from scratch. It's like, no, they're starting from here. They're starting up here now. They're starting from a point where they're informed and can continue to make the decisions for the betterment of their entire infrastructure set that they're responsible for. So the benefits for different arms and different groups and different entities within the delivery of a project are variable. And it's, for me, the first question I always ask people is like, great, you want a digital twin? Okay, What's the question you're trying to answer? What's the challenge that's causing you to bang your head on the desk or get frustrated? Like, well, I can't do this. Okay, well, let's create the content to get to that. And if you want to call it a digital twin, sweet. As far as we're concerned, it's a combination of data sets you've brought together to answer questions. Everything. Seriously, everything.
Okay.
From it's an interesting thing within my own group. We were talking about, creating a spatial data cube, so understanding different themes of data for different project types at different scales. Because we were talking about it's like the same functional pieces that we're talking about here that make up a digital twin, the sensors and such, can be applied just as easily from a single city block. I'm based here in Denver. It might be downtown doing some work at the state capitol, looking at irrigation for the plants in the gardens. Great, you could build a digital twin for that. We've also gone and built out effectively digital twins for the entire continent. The scale of data we're talking about is very different. The resolution of the information is different, but the pieces that sit behind it, as far as I'm concerned, it's kind of the same thing. So I don't see any limitation on the scales for within which a digital twin, again, in the broad sense we're talking about, can be applied.